Hey, hi everyone. So today I am talking about a front-end system design concept. It is called virtualized list. So when we have a problem, like we are rendering a large list in the browser, so let's say 20k items or plus. So there are some problems that occur. So what are those? Like if we are just rendering that list, so all items are rendered at once. So React creates DOM nodes for every item, even they are not visible. A high memory usage is there. So browser stores thousands of DOM nodes, which increases the JavaScript heap size. Slow initial render is there, as rendering many items at once blocks the main thread. Poor scrolling performance, like browser struggles and to repaint, yeah, reflow as you scroll. CPU spikes. Every state update can trigger re-render of the entire huge list. So these are some problems that occur if you just render a very large list in the browser. And here comes the virtualization or the virtualized list, which can solve this problem. So internally, we can say it uses the like the browser intersection observer API, and we can use some library to achieve it. Like I have created a simple project where I have used 10 stack React Virtual. So with the help of that, I have achieved virtualization. So let's see how it helps. So basically, what it does, it only renders the visible items. So React creates the DOM nodes just for the items in the viewport. The memory usage is low, initial render time is fast, we get smooth scrolling and reduced CPU load. So all these benefits, like we can see, we can get with the help of virtualization, like the virtualized list. So let's see this example I have created. Uh, a home page which is rendering big list or either big list virtualized. So how the big list looks is it is rendering a divs of 20 like 20k divs it is rendering, and just rendering these items in the browser it will consume a lot of memory and things will be laggy, uh, and with the help of virtualization, like I have used this library 10 stack React Virtual. So what happens? Like we get a virtualizer using this use virtualizer hook, and we define some things like what are the total number of items and what is the parent ref, like inside, like we are scrolling like the container, estimated size of each div or the each items, it's a 50 pixels, and there is an overscan, like if we want to overscan, like render 5 more extra items. uh, in this way, like this is we use this, like the virtualizer gets us only the visible items and render it in a view and translate them. So it renders at the correct position those items. Uh, so let's see how this looks in the browser. Okay, so let's say currently I'm rendering a big list without any virtualization. So you can see it is still loading and it is taking a lot of time. So see, the heavy load is already happening and it is taking a lot of time. Mhm. So see, if you can see, so many like 103413 DOM nodes are rendered on the initial time. You can see the largest contentful paint is 220 27 seconds, and like we have this huge list, and if we can see the elements, those are rendering. So like we can inspect those and see are they actually rendering or not. So yeah, these are coming, but if you like go very down and check this, so like inspect it. So this browser is like lag, and I'm not able to, like the arrow is not visible. So yeah, if you can see, this div is there, but still no content are there. So the browser is processing these things, and the values is still not there. And you can see the JavaScript heap size is 58 MB. Now let's compare this thing, and the CPU usage it increases and it's drop, so that is fine. But let's compare it when I render a virtualized list. So let's start from start, being like local host this thing, and you see how fast it just loads it. And the DOM nodes are very minimal, 181, and the heap size is only 14 MB. So what is happening here, if you can see, only a fixed number of items just render in the DOM, and the other extra items are removed. So the load on the browser is like very less, and you can see the JavaScript heap size is around 49 MB. You can see the DOM nodes are increasing because it is just calculating the whole number of DOMs that are getting created. So, but on the view, there are currently a fixed number of items, so it just improves the performance. So, I have like taken some screenshots to compare the performance. Um, so let's compare it. So in a like web browser, uh, after opening the inspect tab, we can type like Control Shift P and search performance monitor. So like if we are directly rendering the 20k rows, we can see the JavaScript heap size is 133 MB, and with virtualized list it is just 18.3 MB. And second thing is like taking the snapshot of memory. So without the virtualization, we can see the snapshot is 114 MB, and like with virtualized list it is like 17 MB and 20 MB or 21 MB. So a very less memory is there in the browser when using virtualization. And third metrics I have used, like in the performance tab I've recorded the performance. So if you can see, the scripting is taking 2.5 like the seconds, or we can say 2594 milliseconds. So it, like for that time, the JavaScript is working, like rendering the so many items, so very high scripting time. And when we compare it with the virtualized list, it is like 372 milliseconds, far less JavaScript work because only visible items render. Okay, so rendering time, if you can observe, like 392 and 7 millisecond. L- Long total timeline, so it is like 14 to 18 second range, and it is 0 to 5 second range, which means faster load and smoother behavior. And long time takes like page works keep happening for a long time, slow load and scroll impact. So you can see how we get the performance benefits like with the help of virtualization. So this I wanted to discuss, and yeah, so that's it for today.